So again, I went through the Illuminate test. So when you say, Mr. H, why do you care about the Illuminate test? The Illuminate test are those scores back there. The Illuminate test is about what gets us ready for the MAP test. The MAP test is the end of the year test. I have no idea if it's going to happen this year because of everything that's going on, but it has not yet been canceled. Therefore, that's an important test. It's an important test for you guys. It's an important test for the school. And I'm not going to lie, it's an important test for me. So, questions 1 and 3 were from that test, and it was one of the things that I saw that we didn't do so well on. If that sun's right in your eye and you need to move, if you want to move over here, you can. That's up to you. Okay, just let me know. So, the first thing we have here is this is called a power raised to a power. Who remembers what we need to do when we have a power on the outside of those parentheses? Anybody have a guess? Montana?
Multiply by the inside.
Yeah, we're multiplying every exponent. So let me switch colors here. Where's my blue marker? There it is. We're going to take this exponent that's on the outside and multiply it to every exponent on the inside. So one version of simplification could be I keep the base. 2 times negative 2 is negative 4. 2 times 2, I keep the base. I put a positive 4. That's one answer. That's one answer. Is that wrong? If this was algebra, I would mark that wrong. Pre-algebra, that might be one of your choices on a multiple choice thing. Because on the Illuminate test, it said choose all of the possibilities. Everybody still with me? Why? Can you still hear me, man?
Yeah, I can hear you.
Okay, because I can't see you, so just kind of chime in every so often, okay, man?
Okay.
So another possibility. Do we like having negative exponents? What do we do when there's a negative exponent? Does anybody remember? We have to make this into a... This is where I think a lot of us got confused. We have to make this into a fraction. Because to get rid of the negative exponent, we keep all of our positives, not just the base, but the exponent. And then to make it a positive exponent, where does it have to go? Maurice?
To the denominator.
Very good, to the denominator. And it becomes 3 to the positive 4. So this could also be one of the answers. And then we've got another one. We've still got one more answer. This is where you're going to need to get your calculators. And when I say one more answer, we've got 2 more. So get your calculators. Oh, hold on. Where did Mr. H make a mistake here? Maurice? On which one?
For 2.
For 2. This should be not 2 squared. I was looking up here. It should be 2 to the 4th. I apologize. Still with me? Okay. The other way of simplifying is getting your calculator. I'm going to talk to the people with the yellow calculators. So turn on your yellow calculator, please. If you have a blue calculator, it's going to be about the same. I'll help you in a second. I physically want to do 2 to the 4th. So I'm going to press 2. And then if you look at the 7, go to the left, there's an x squared button. Go above that, there's an upside down V. That's called a caret. Press the caret and then press 4. 2 caret 4, press enter. 2 times 2 is 4 times 2 is 8 times 2 is 16. That should give me 16. So now I have 16 divided by. Let's do the same thing for 3 to the 4th. 3 times 3 is 9 times 3 is 27 times 3 is 81. There's another answer. All of these are good simplifications. It might say on your Illuminate test, choose all that work for simplification. Okay? Questions on this? Anybody? Does that make a little bit more sense now? Do we remember doing this? Okay. Now we're getting to a little bit trickier. Wyatt, you good, man?
I'm good.
Okay, bud. What are my like terms in number 2? Okay, I've heard a lot from Maurice. I need somebody else because I've got several people who are in my Shine class, and we've done this in Shine. So which ones of these are my like terms? I've got 1/3 x plus 7 plus 1/2 x plus 1/3. Go ahead, Leah.
1/3 x and 1/2 x.
Can you say it a little bit better for me? 1/3 x and what? What kind of 1/2? What kind of 1/2 is it?
Over 2x.
No, you're right.
Positive.
Oh, positive. Because when we're combining like terms, we include the number and the sign. Okay, so there's a couple different ways we can do this. I can do 1 divided by 3 in my calculator plus 1 divided by 2, and I get a decimal. Okay, so let's do that. So let's use our calculators, because our calculators are going to be our biggest help in Module 4. So we're going to do 1 divided by 3 plus 1 divided by 2. And it should give me 0.8333333333333333333333. Yes? Is there anybody who did not get that? Now on these yellow calculators, to change it to a fraction, we press second, table, enter. And it should give me a simplified fraction. So press second, table, enter. And what did we get? Bailey, what'd you get? 5/6. I absolutely agree with 5/6. What does 5/6 need to have with it? Maya?
X.
The x, because we're combining the x's. Very good. Okay. What are my other like terms? Hannah, what are my other like terms?
+7 and +1/3.
Good. +7 and +1/3. Those are called constants. Constants do not have variables. They're just numbers. Fractions and whole numbers are still constants. Get your calculator. Do 7 plus 1 divided by 3. Press enter. Oh, we get 7.3333. Press second. Table. Press enter. And now we get a good fraction, which is 22/3. Can I combine the 5/6 x and the 22/3? Can I combine those? Are they like terms? I see a lot of heads shaking no. We can't combine a coefficient, which is the number in front of a variable, and a constant. Variables and constants cannot be combined. So there's my answer there. How's my time? Oh, we're good. Okay, still with me? Okay, moving on. For number 3, we're simplifying by dividing. This is a 2-part problem. We rewrite it as 3 divided by 9 times 10 to the 10th divided by 10 to the 3rd. So let's do 3 divided by 9. Get your calculator. Do 3 divided by 9. What do we get?
0.333.
0.333. Yeah, 0 and 3/10 repeating. I'm just going to go 4 spaces out. Times. We keep the base. What do we do when we're dividing exponents? Do we add? Do we subtract, Hannah?
Subtract.
We subtract. 10 minus 3 is 7. If you put this as an answer, depending on what the question says, that's not wrong. If it just said simplify, that's not wrong. If it said put into scientific notation, this is wrong. Because the decimal needs to move which direction? Levi?
Right 1.
Right 1, because our first number, so we know it's 3.333 repeating, needs to be between, the first number needs to be at least 1, but less than 10. So if I moved it to the right, do I add 1 to my exponent or do I subtract? You got a 50-50 shot. Add or subtract? What do you think? Give me this. Give me a add 1, so 10 to the 8th. Give me a subtract for 10 to the 6th. So show me with your fingers. Perfect. We're subtracting 1 because we're taking 1 place away from it moving. So it is going to be 10 to the 6th. Hold on. No, I'm good. Okay. Shoot. Questions? Last one. And this is, I don't want to say the most important because it's not the most important, but we are going to be spending a lot of time solving equations in Module 4. And a lot of them are fractions. I'm letting you know right now, which is why you're seeing a lot of fractions. So, in this process, we find our balance point. Step 1 for equations is going to stay the same, and we're going to have an anchor chart for this. We distribute if we can. Well, I can. 1/3 times 3, 1/3 times -9. Distributing means multiply. 1/3 times 3 is 1x. 1/3 times -9 is -3. And you might say, Mr. H, how did I get that? Well, I used my calculator. I did 1 divided by 3 times 3. I got 1. 1 divided by 3 times -9. I got -3. Okay, so your calculator does this. I haven't touched this constant, so it comes down. Equals 6. So after we distribute, we combine like terms on the same side. So by same sides, I'm looking left side, I'm looking right side. What like terms do I have on the left-hand side? Maurice?
-3 and +2.
Thank you for saying it like that. -3 and +2. I didn't touch my x, it comes down. -3 plus 2 is -1. Equals 6. Still with me? Okay. Then we're combining like terms on opposite sides. This is a -1. When we're going to the other side, it is the inverse operation. The inverse of subtracting 1 is adding 1, because that is the additive inverse property. That gives me 0. So now I have 1x equals 7. 1x equals 7. Is 1x the same as just x? Remember, a variable by itself always has a 1. So there is my answer. Questions? It's a little bit longer of a warm-up today. So make sure you have that copy down. I'm going to hand out your tests. If you do not get a test back, that means you did not take it, which means you need to come and see me so that you can take your test. I'll find you over. This test was curved, which means instead of having it out of 100, it was out of 85. So if you take your top score, you divide it by your bottom score, it will give you a decimal. So if you take your top score and you divide it by your bottom score, it will give you a decimal. So that would be your percentage out of 100, except it's out of 85 points. So then you'd have to take that number and divide it by 85 to get your actual grade. Where's my book? Here's the actual test. Here's the actual test. Okay. I will be glad to help you go through anything. The biggest thing that caught me off guard was we forgot to use proportions. Here is the key for the day. If you see similarity, if you see dilations, if you see something like that on your map test, on a quiz, on a warm-up, assume that you need to set up a proportion. Because remember, similarity has two things that have to work. The corresponding angles must be congruent, and the sides must be proportional. So here's what I need you to do now. Make sure that your test is put away. get out your Module 4 packet, please. There are some of you who have not yet received that, but I would be glad to get those for you. Thank you. Okay, I'm also handing out some keywords to you. Okay, these should be, you're welcome, should be a help to you as we work through this Module 4 packet. Because the first start that we're doing is talking about how to change numbers, or how to change words into numbers. Does everybody have one of these things that says word problem keywords? Yes, no, maybe so? Wunderbar. Okay, where's mine? There it is. Hello. If I am remembering correctly, Mrs. Blair did all 5 examples. Is that correct? What she did not do was the problem set. So I'd like everybody to flip to page S2. And let's look at the summary. Begin all word problems by defining your variables. So what that means is when we have a variable, we're going, put it away. When we have a variable, whatever it happens to be, you're going to say X is the cheaper ice cream cone. X is the most expensive. Yes, Montana.
I don't have one.
Were you here? Let's just get you another one. There you go.
Thank you.
You're welcome. So whatever the variable is, you need to say what it means. You can't just start putting X into an equation when it's a word problem. So written mathematical statements can be represented as more than one correct symbolic statement. What that means is your equation might not look like my equation, but that's all right as long as they're equivalent. And then break complicated problems into smaller parts or try working with simpler numbers. So here we go. Let's take a look at number 1. Number 1 on the problem set says Bruce bought 2 books. Okay? So we know how many books are there? 2. One book costs $4 more than 3 times the other. Together, the 2 books cost them $72. So here's what I know so far, and this is how I would break it down. I know that Bruce has book 1 plus book 2, and I know that equals $72. Does everybody agree with that? Is that what the statement says? Now, does it tell me a little bit more about it? It says one book costs $4 more than 3 times the other, correct? So we should be writing this stuff down. All right. Okay. So one book costs $4 more than the other. Well, let's start off with the book. So the book is going to be X. One book costs $4 more. The book plus 4. Still with me? What else do we have to add to this? Well, we have to add book 2 to equal $72. How much does the other book cost? Read what it says. What's the statement, Maurice?
3 times more.
3 times more. So How am I going to show? Well, here's the book. How am I going to show 3 times that price of the book? How do we show that?
3 times X.
3x. There's the equation. Now, is that easy for me? Yes, it is. Is that confusing for you? Probably a little bit. Does it get easier? Yes. Now, the thing that it says that we have to do is also define the value of x. X is the cost of one book. And really, it's the cost of the less expensive book, but that's all right. Okay, it's the cost of one book. Questions on that? Okay, so now you're going to help me with number 2. Now it's your turn to help me with number 2. So number 2, it says, Janet is 3 years older than her sister Julie. Janet's brother is 8 years younger than their sister Julie. The sum of all of their ages is 55 years. So, what 3 things do we have? So look at that problem. What 3 things do we have? Because this is how I'm breaking this down. Leah, give me one thing. Give me one person that we know. Okay, so we've got Janet. Plus, who else do we have? Levi.
Julie.
Okay. Plus who? Who else do we have? Maya.
Janet's brother.
Oh, the brother. And they all equal the sum. Sum means we're adding them all together. What do they have to equal, Sammy?
55 years.
Yeah, 55 years. Perfect. Okay. So now I've got a basic thing to help me start filling it in. So let's read it again. It says, Janet is 3 years older than her sister Julie's age. And then it also says, her brother, Janet's brother, is 8 years younger than her sister Julie. So we're basing both Janet and her brother off of who? Who does it say that we're comparing Janet and her brother to? Hannah?
Julie.
Julie. We need Julie's age. So Julie is going to be the variable. Read about Janet again. What does it say Janet is? Go ahead, Leah.
3 years older than her.
Oh, 3 years older than Janet. So Janet is 3 years older than Julie, right? Is that what it says? So we've got Julie. How am I going to show that she's 3 years older than this age? Julie, what? Go ahead, Maurice.
3x.
Not 3x, it's multiplied. How would I show her she's 3 years older? How old are you, Levi?
14.
How would I show that somebody's 3 years older than Levi? What would we have to do to Levi's age?
Subtract it.
So that would make them 3 years younger. Go ahead, Minnie. Add it. So there's Julie's age plus 3. So there's Janet. How about the brother? What does it say the brother is? Good, Maya.
8 years younger.
So how am I going to show that?
Subtract 8.
From what?
X.
Oh, from X, because it's Julie's age minus 8 equals 55. There's my statement, but we're not done. X is what? What did we say that X represented? Hannah.
Julie's age.
Very good. X is Julie's age. This is where it says, if you look at that lesson summary, and it says, hey, begin word problems by defining the variable. This is defining the variable. Questions yet? Okay, you're going to do one on your own, work in your groups. I would like you to do number 5. Because that is an equation that you will end up solving. Number 5 says, when you add 18 to 1/4 of a number, you get the number itself. So you add 18 to 1/4 of a number, you get the number itself. Talk it over, see if you can come up with it. I think this is number 5, right? And guys, I'm not going to lie to you. This is not a, oh my gosh, I can teach you exactly how to do this because it follows these steps every single time. It doesn't. Word problems are something that you have to actually understand. And it takes practice to understand them. I'd love to give you here's the method, follow step A, B, C, D. But there is no method to follow step A, B, C, D. You actually have to understand what you're reading. So I've defined it as X is the number. Okay, because we don't know, could you use Z, could you use Y, could you use P? Sure, have a variable as the number. It says, when you add 18 to 1/4 of a number. So what are we going to add? What 2 things are we adding? Bailey. 18 plus 1/4 of a number. Let's go to those keywords that I gave you. Do you see the word of? Where does of fall in? Montana.
Multiplication.
Oh, so if it's 1/4 of a number, we're taking 1/4 times a number. What did we say the number is? Caitlin. Oh. So now I have 18 plus 1/4 x. And then it says, and I'm still going back to my paper so I can read it. Where is it? Oh, you get the number itself. So what does it have to equal? Maurice? Yeah, the number. It has to equal x. And that's what we're looking at there. Questions? Okay, so as we look at all of the 3 examples we've done, Mrs. Blair did the whole first page. She did all the examples for the packet. These are from the problem set. When I look at these, they all can combine and give me an x, 3x, 4x, 5x, something like that. Anywhere in these examples, do you see an x squared? No, we don't see an x squared. We don't see an x to the third. Do you see something like 3 divided by x? Do we see anything like that? No. Okay. So these are what's called linear equations. Linear equations. If it is not just an x squared is not linear. A 1 divided by x is not linear. X to the 4th is not linear. So that's what we're talking about in lesson 2. So go to lesson 2, please. So flip your page. I'm again pretty sure that Miss Blair did all of the examples. Is that correct? I'm using yours because I see that you did it. Yeah, she did all of the examples. Go to page S. I think it's going to be, 5. to where it says a lesson summary. If you have a highlighter, this would be a good thing to highlight. So if you look in the lesson summary, it says a linear expression, and then it shows you several linear expressions. I would highlight that. So linear is 4 plus 3x, 7x plus x minus 15. 1/2 of an x plus 7 minus 2 are linear expressions. And then it talks about non-linear. 2x squared, negative 6x to the negative 3, 1 divided by x. Knowing the difference between linear and non-linear is important. Okay, so we're on that problem set. I know that you're still highlighting. I'd like you to circle number 1 and 3 on the problem set. In your groups, I want you to, just like we did in lesson 1, all I want you to do right now is to write the equation or the statement or the expression. It doesn't have to be an equation. It can be an expression, which means there's no equal sign. So you are reading numbers 1 and 3, and you are going to write the numbers. Don't worry about linear or nonlinear yet. Just write the numbers. 3, 2, 1, go. So talk it over. Number 1 says, a number decreased by 3 squared. Number 3, the sum of 13 and twice a number. Give them a try.
The sum of 13 and twice the number. Now you just leave that in. The sum of 13 and twice the number. See if we can find any of those words in this one. See that number 1?
Okay, here we go. So number 1, once again, it says a number decreased by 3 squared. So let's define the variable. How are we going to define the variable? This is where we say something like x is, y is. Somebody help me define the variable. Go ahead, Maurice.
X equals a number.
X is a number. Perfect. Bailey, what did you get here? X minus 3 to the second power. Give me a thumbs up if we got x minus 3 to the second power. Love it. That's what 3 squared is. Now, here's the next question. Is this linear or non-linear? Maya? Why do you think it's non-linear? Okay. I'm so glad you said that, Maya. Maya said this is non-linear because the exponent is more than 1. Is that correct? You are so close. You're understanding the general concept, but we only care about the exponent on the variable. What's the exponent on the x? Does it have one? There's not one there, so what does it have to be? 1. So it doesn't matter if anything else has exponents. The variable has an exponent of 1, which means that this is linear. Okay, you are absolutely right in understanding, man, it can't have a squared, but what can't have a squared? The variable. Okay, very good. Wyatt, you still with me, my man?
Yeah, I'm good.
Okay, and number 3. Number 3 states, maybe, the sum of 13 and twice a number. So what are we going to have as my definition for the variable? Somebody help me out who I haven't talked to very much. Zoe, can you help me tell me what x is? X is a number. Very good. So x is a number. We don't know what that number is, but we know that x is defining that number. So one more time, it says the sum of. Sum means we're doing what mathematical operation? Maya? Adding. So we're adding 2 things. What 2 things are we going to add? Faith, what do you think?
We're gonna add 13
Okay.
and
What does twice mean?
multiplication.
What number are we going to multiply? If it's twice.
2.
Very good. 2 times what? Twice what does it say?
A number.
So 2 times?
X.
Beautiful. 13 plus 2x. I love it. Is this linear or non-linear? What do we think? Give me a thumbs up for linear. Give me a thumbs down for non-linear. So this is where you're going to put your hands up. It is linear because the exponent on the x is still a 1. The reason I wanted to do this one is because twice a number, I wanted to see if you were going to do something with the squared. Twice means 2 times, not to the exponent of. Questions, concerns, problems? Okay, let's roll over here real quick. Wyatt, can you see, sir, that blackboard?
Yes, I can.
Okay, so we're here. We're doing 1 and 2. This day is now done. Watch how we're going to do this. 1, 2, 3, 4, 5, 6, 7. You have 7 days of classes before the semester is over. Okay, just bear with me. On Thursday, we're going over lessons 3 and 4. On the following Monday, we're doing 5 and 6. On Wednesday, we're doing 7 and 8. On 12/11, that's our Friday, you're taking the fast bridge test. So that takes us down to 6 classes because that's not really a class, right? Then you've got a quiz the following Tuesday. So this day, even though you're taking your fast bridge, I'm going to give you a review packet. There will be a video online with all of the answers. It is up to you to go and watch those videos and find the answers because you're going to come back and take the quiz. With me? So there's 2 days gone of our 7. So now we're down to 5 days. We're reviewing lessons 10 and 11. We review lesson 12. And the semester's over. There's not a lot of time. Everybody with me? So just like I told my Rise class, don't be complacent. Don't sit on your heels. If you're right there on the edge of a grade, work for it. We've got 1 more big grade coming up. I really believe that we're going to do well on this. It's going to be some of this stuff, though. Okay? Let's finish this semester off strong. Questions? You're going to have 3 videos in the Google Classroom. You're going to have lessons 3 and 4 and the live video from today. Everybody with me? I am absolutely wonderfully happy to have you guys all back. Watch the videos.